All right. Good afternoon, everybody. Good afternoon, everybody.
Good
Okay,
afternoon.
that's what I like to hear. Great. So thanks for coming out early, and also good morning and good evening to anybody out there in TV land. Just made a honeymooners reference, but anyway, yeah. So yeah, thanks for coming out. I know it's sweltering hot the last couple of weeks. I know, and thankfully we survived. I hope everybody had a good 4th of July. So let's get rocking and rolling here. So, all right, so we're going to do our usual opening slides where we thank our sponsors, what's new. I'm going to introduce Neha to everybody. Then Neha will have her presentation, and then you have to hear me blab again at the end. So let's keep going on that. So our sponsors, our silver sponsor is Azul, and they have an open or downstream distribution of OpenJDK with the coordinated restore at Checkpoint. And they were the first ones to do it. Bellsoft's version, which is like Liberia JDK, they have it as well. So DevNexus, which was an awesome conference this past April in Atlanta, Georgia. They are our partner, and that's run by the Atlanta Java Group. And then our per meeting sponsors are JetBrains, who obviously provide the 1-year license to IntelliJ IDEA. And then Eclipse Foundation and Jakarta EE, they provide, video through Crowdcast for all the Java groups. All right, and we have some memberships. We're guest members of the Jakarta EE working group, the microprofile working group, the virtual JUG, and then the Jakarta EE ambassadors. And who are they, you might ask? Well, we're an independent grassroots group of people committed to moving Jakarta EE forward through active community participation and advocacy. So I think we do a pretty good job of that. So, and I'm on the Leadership Council, and then you can learn more about us at that website down there. So what else do we got here? All right, so what's new? I had this slide last month, but the only thing new here really is that the second ramp down will probably, I think, be next week. I have to double check the date, but they usually have the dates on the different stages before the general acceptance release, which will be in September. So that's the main thing there. And you can see the first half of the features that are available. And then this is the second half of features. So this is all frozen. There have been exceptions where things have gotten moved off after that, but that's very rare. And let's see. Oh, and then today for JDK 24. So this is for JDK 23. The prepare to remove the JNI is proposed to target for JDK 24, which will come out in March of next year. So that's the first one that's under a week review. And it'll most likely be the first feature for JDK 24. We also have two Jakarta EE11. Right now, they're in the final stages of getting the TCK done. They're migrating from Apache Ant, believe it or not, so to Apache Maven for the build tools. I was surprised to learn that, by the way. So in any event, Milestone 4 was released. It's up on Maven Central, and you can get all the latest features. All of these specifications have gone through their release reviews and are set for Jakarta EE 11. And then Jakarta Data, if I can point that out, is the newest specification that's on the platform and the web profile. All right. So I'd like to introduce Neha Sardana. She's been on our leadership team for the last at least 3 years, if not more. So we're happy to have her help out, and she's gotten some speakers for us. That kind of work that she does in the background there. So anyway, and by the way, it is Neha's birthday today. So let's
Thank you so much.
So what are you, like 22 now or something like that?
I wish, but
No, you don't.
no,
Announcement.
no age revealing, please.
If people showed up.
Yeah.
then they would be able to avail themselves of our celebratory donuts.
That's right. So we went and got Dunkin' Donuts as was part of as a dessert for the pizza pie. So yeah, like I said, Neha's been part of our leadership group and been working as a software developer since 2008, primarily in Java-based technologies. She has experience working in the financial industry in both North America and Europe. She's a technologist and an open source software enthusiast and loves to talk and blog about all things open source. We're very happy to have you. Thank you for coming out on your birthday. This was your idea too, by the way. So
You said, let's do it on 9th. I was like, okay, let's do it on 9th.
Yeah.
Why not?
I mean, we always strive for the second Tuesday of the month. This goes back in history, a little bit.
I didn't have to
but-
take a day off from work. It was already my fun day. So I'm having fun here.
And we're happy to have you here, Neha. It's a pleasure to be with you here. So
Thank you.
without further ado, please come on up.
Thank you.
And we have stickers. There's more, but and then pizza and the donuts, and I left the bag here. So
Okay, I have a secret to tell you. I made this like 2 days before because I could not bring my presentation to my personal computer. So long story. Let me do this. Can I move this around? Hey, Mike, I'm not able to move this.
Oh, I can,
somewhere.
you want to get that out of the way?
Yeah,
The only thing is that
I got it.
I think it's over there.
I
right?
got it under control.
the body did good work.
That's right. And with this thing.
I think it's
Huh?
good now. Oh, okay. With this, okay.
There we go. I think we're in good shape.
Perfect. So first of all, thank you so much for coming. And I don't know, I don't have any words to thank all of you, especially our leaders group, executive groups, Mike, Barry, Paul, all of them. They have been so grateful last couple of years. And even though this is my first time in person, I'm a remote worker, by the way, but they have been so patient with me. Yeah, you know that, what I mean. So, okay, I want to ask first, how many of you do know about Scala or some sort of Scala? Good. Yeah, we have a good start. How many of you know Java, like well enough? How many of you know records and seal classes? I just want to analyze. Oh, good. So you do know basic stuff. So again, a next question. What's your first thought about Scala? If you come across or if you've heard about it?
Complicated. Big
Good-
language.
Good
big,
point.
big.
Anyone else?
Whoa, here I come.
Okay, I don't
You
know
said
Rust,
looks like-
but
Looks like
Well-
Rust.
he said it looks like Rust. I don't know. I don't know Rust. I think I'm confused between Java, Scala, and Python word enough. So, and please don't ask me anything about Kotlin as well. I wanted to put a disclaimer because I know a lot of people have said that it looks like Kotlin, but I'm not a Kotlin developer. So let's see what Scala has to offer. So Scala is complicated for many Java developers. It's very common to see it that way. But I want to make sure that you have enough tools by the end of this session so that you can get started. It looks complicated, but it's really not that complicated. So, and we have a quiz at the end, we will test that. So this was me practically in a girl's attitude or, picture. This was me looking at my screen at my Scala code. How many times do you have to write a code and not read it? People write code for you. I feel like the entire software development life cycle is like reading others' code. And when you read a Scala developer's code, it looked like I literally had tears in my eyes, what I'm looking at. But it's not really that complicated if you look at and compare some things from Java, because they have a lot of things in common, especially with the record classes, seal classes, And with the functional paradigm shift, you can see there are a lot of similarities, and that's what we are going to cover. Yes, this is my agenda. So that was my first question. Why do you have to learn Scala? Like, there are other languages, there's Java. Why would you actually care about Scala? That's the next slide. So I'm going to be patient. So we'll see the synergies, differences, and then the entire focus shifts on functional and OOPS concepts. And then we'll start looking into pictures and stuff. And I have some language spotlights, like key features that you want to see. And when you get started, that's most regularly you're going to see in Scala code. Java and Scala, they are like siblings. I call them a siblings relationship. Like Scala is like the eldest sister, and Java is like the big brother who's like protecting, taking care of backward compatibility. And Scala is more like, I don't care what I wrote next day. Version 2 and version 3 doesn't match. I don't care. I care about keeping the code concise, and I just want to write my stuff. I don't care about the other stuff. So in a way, we'll look at the Scala 3 features. I've tried to incorporate the new features. I'll give a link at the end of a GitHub site where you can practice all of these things here, so you don't have to worry about the code and stuff as well. And again, we have a quiz, so I really like the quiz. So little things about me. This is my daughter, by the way, and this is why I'm not here in person more often, because she keeps me busy all the time. This is my second job. But and the fun fact is, it took me 3-4 attempts to take her into this position to laugh and click a picture. So it was a few attempts. So I work at Morgan Stanley. Basically, I write code. That's what I call it. And I also have some relationship with the Garden State Java user group, I think so, and with the New York Java SIG in New York. And yeah, I've been writing Java applications all my life. So when I recently came across Scala, that's why my face went up like that. So, and you can find me here, all my GitHub, Twitter. I have a few blogs as well. All the links are here. So you can just scan and get the link. She's home, probably watching me on YouTube. Okay, so this is from JetBrains 2023. 2024 hasn't come up yet, but I thought this was an interesting feature. So Scala developers are actually paid more because, first of all, there are less number of Scala developers. Scala looks complicated, so a lot of people, they don't want to spend the time and energy on it. And we write stuff that goes and becomes a legacy code. So people have written stuff in the past, like 10 years ago when Java was still on 8 for a while, and we didn't have any features like records or sealed classes or pattern matching. So in order for the industry to do some work back then, they introduced Scala. And once they introduced it, somebody has to keep it up, right? So you just don't go write a new Scala code. You sometimes have to read the Scala code. That's more complicated than writing new code. So there's seriously a lot of more money paid to the Scala developers. So that I think that would give you some benefit that, you know, it will pay you more as a Java developer comparably. So I thought the numbers are good enough. Anyways, we also noticed that there's a release history. And if you look at the number of releases, it's actually not bad. Java does 2 releases every year, I guess. And Scala is doing at least more than that, 4 minimum, 6 so far. You can see all these parallel releases, including 2.13 version, which is still, they are kind of supporting it because Scala version 2 is not really compatible with Scala 3. So you have some rewrites there. But I think the idea behind it was the architects felt that they really want people not to use certain features and move on to something new and better. So I think that's why they are still kind of supporting 2.13. Okay. you know Java, why do you should know Scala now? It's a very common question. First of all, it's a very concise syntax, even though it might look complex, but if you look at it, probably by the end of the class, I would see if you are okay with the concepts, it will look concise enough to use. It is actually built up completely functional and oops. So all the object-oriented principles are embedded in there. They are by default. So you can't just have your way around by not creating or working with functions. Like with Java, you have certain, nuances that you can try. You should use functions, but you can, skip them if you don't have to. There's a mindset that needs to be driven by a developer. But with Scala, everything is a function and everything is object-oriented principles. Everything is wrapped around an object. So you can't just, you don't have any options there. One of the first thing that I really liked about it is the type inference. I always thought we have the var keyword, which makes it simpler in Java, but with the type inference that Scala has, it takes it to a completely different level. Because I remember with var symbol, Venkat, he gave a talk. I think he spoke about it for an hour, and he gave an idea that it winks at a compiler, but at the end you have to be careful enough when you're using var. Mostly it's not. It's easy just to replace it, but it's not the same thing that actual type inference is doing. So languages like Python, for instance, they have a good type inference. They are not. You get the world of Java, but in a Scala way. I'll show what it means. The other thing is companion objects. So this was something that I saw. I have an example of each one. So I think we'll go over it. But companion objects are basically singleton objects. In Java, you will have an opportunity to create a singleton. Programmers are asked to create a singleton. You should have one instance of an object. And it's easier that ways to program. But it's embedded in Scala in a way that you cannot escape yourself around it. So it's preferred that ways. Immutability is inbuilt. So all the Java collections are not immutable by default, but in Scala they are. Pattern matching, even though Java has pattern matching and introduced it, Scala takes it to a new level. Like all the data structures are supported and everything is there. I'm going to try to go with these last three concepts. Actually, not last three. The conceptual abstraction. I think it's contextual. I have a typo here. Sorry. Contextual abstraction. These are something which is well explained by a code. So I'm not going to write anything right now. Monads are nothing but, let's say you have option class in Java, similar way you have in Scala as well, but it's all of these are features that are given to you by default. So you kind of use it more often. These are some of the common things that you might see in Java and Scala. So both of them, they are compiled to a .class file. So everything gets converted into a class file and it runs on JVM. So whatever you're writing, you do have to remember that it's running on a single JVM, if it's a Java code or if it's a Scala code. Then it's, again, I keep telling about functional and oops, but we'll see it. They both operate on the same garbage collection principles. So the strategies of the JVM, since it runs on JVM, they have the same garbage collection. They both have sort of strong typing as well. Like the recent versions of Java, with Scala, I know with Python, recently I did some Python coding as well. With Python, the typecasting, the type of an object is very loose. And with other objects, other programming languages, it's also there. But since it's a Scala in a Java world, it's kind of inheriting that feature from it. That's why I called it a sibling. So in a better way. Then you have the similar exception handling. Interfaces are very similar and they are classified as traits, but there are a few differences which we'll cover in a few more slides. Records, they are very similar to case classes, but again, there are some features in Scala that they are not in Java yet. We also talked about pattern matching, concurrency and parallelism the same way. They both actually have a standard library. So there's no string class in Scala. It's actually inherited from Java. So they have a lot of common library sharings. And java.lang is actually by default imported when you create a Scala code. So you inherit a lot of features from Java already. So there's a lot of things common. And tooling and ecosystem as well. So I have an example here to show. I'll give a link as well. But the example is not built on SBT, which is the default build tool. You can use Gradle in it. So I wanted to do Gradle with Scala because a lot of times when you work in an organization, you don't get to choose which build framework you are working with. You just thrown it on you, which was happening to me as well. So I thought it would be a nice idea to create it on Gradle. So rather than using SBT, but SBT works with Java as well. So if you're trying to create a Scala project, you can use Java and, Gradle and or SBT, or there's a framework called Mill as well. So that's also there. Now, key points for Scala. Scala is very expressive. Everything in Scala, even if you just want to print out something, is returning something. So if it's, there's nothing as void basically in a Scala world. Everything has to have to return something. And if you think about it, think like a function. If you know, if you have done any mathematics in your previous classes, you know a function has an input and it gets an output. Simple thing. So in Scala, you cannot have something which does not have an output. Even a print statement, like which is not returning anything, that returns a unit. So that's also an object that's being returned. It's very dynamic and it's pure functional because functions are considered first-class citizens. So the syntax of a function is really, really simple by default. And there are no primitives in Scala. And that's one of the key advantages that you don't, that's one of the reasons why you call it pure OOPS language, because there's no concept of primitives like we have seen in Java. And like I said, did I write expression and expressive 2 times? Okay, sorry. This was my last minute mistake. I'm sorry. Yeah, and then the funny part in Scala is that you can create your own operators. And I have an example as well. I'll show you in a few slides later. But just imagine even the plus, multiply, divide, or minus, any operations that you do in Scala is actually an operator. That's a method that you're going to operate. And you can create your own custom plus, but just don't be crazy about creating them because it will be so hard sometimes for others to read. But you have a full opportunity to create anything you like, any random thing. And yeah, I mean, Scala is immutable. So we do have opportunity to have mutable objects in Scala, but it's not really preferred. They always use val instead of var. We will see that example as well. Okay, now I have to see why it is better. I already explained some of the things like functional plus OOPS. They both kind of work together, in my opinion. Functions get priority here. So all of the things that you write is a default function. Everything is an expression. There are no primitives. Actually, and companion objects, we'll see that example again. But the difference that we have, like I explained it, traits and interfaces. So traits in Scala, they can actually hold a state of the object, which is not possible in Java. Because in Java, you can create a default method and you can have static variables, but you cannot have instance variables. Remind me if I'm wrong in Java because it's been a while. But in Scala, you can do that as well. So if in case you want to hold a state on a trait, you can do that. You can actually mix traits as well when you implement them. So there's no such thing as implements in Scala. You just extend the trait, not implement like in Java. And in case classes, it's one of the good features in case classes that they have an apply method. Like you in function, in all the functional programming paradigm, you have a by default apply method, which is also there in Java. But in records, when you compare it with case classes, you don't have a apply method. So that gets inherited by default in case classes. And also because records are POJOs, I forgot to add it in a slide, but you cannot extend records, because it's already extending a class record. But in case classes, you can do that as well. So that's a possibility. So again, pattern matching is there. You have a powerful type inference and all these things I have already talked about. And yeah, this one I've not mentioned. There's an inbuilt dependency injection. So with Java, we have used frameworks like Spring, where you annotate and you inject your class as a dependencies. With Scala, you can actually do it without using any third-party library. So you are dealing with something which is directly inbuilt with a normal thing. So this was released recently. The code I'm going to show you is actually version 3, not 3.4, but it still works. So this is where you want to go when you want to start working on Scala. And very good thing I like about is they have a playground. If you see a red arrow over there, I don't have a clicker, but yeah, if you see a red arrow over there, there's a playground. There you can actually just go and type in your code and you can practice. It's like a REPL. It really works really fast and it has a lot of advantages as well. Plus, if you go into the documentation, there's a lot of stuff added to it. And there's also a column or a section here, which is specifically dedicated for Java developers, which is more like, from your perspective, from our perspective, which you think about Java, whatever I'm mentioning here, it's actually there as well. Okay, so I created this GitHub repo. There are some changes I've made later, but if you want to scan this and keep it somewhere, we are going to see all these examples here, and I'm going to add more examples because I added it at the last minute as well. So this is just for your reference if you want to save it. Okay, so this is the time where actually you want to see code. I'm pretty sure you're bored now that I'm talking about what the hell is Scala. Okay, so let me briefly show you. Okay. Okay, can you see the screen really well? Is it okay? Okay, so I created this app. So if you go and look at the left side, this is a Gradle app. So in order for me to create this app, it took me, it wasn't bad, but if you clone my repo, you can easily get started. But if you want to start from scratch, you have to go to Gradle, you have to download the Gradle CLI and create a Scala project from there and add all the Java dependencies and all those stuff. And there's also a version compatibility matrix. So this is working on Gradle 8, which is the latest version series, not 7, and using Java as a JVM, which is 17. I tried with 18, it did not really like it, but I think in a while I'll be able to update it to 2022. But I needed 17 so that I can show records and comparison with that as well. So a simple program would be here. So let's go and look at the fun stuff. So if I go here, I've created a GS jerk. Okay. Do you see it, right? Okay. So So first of all, let me wrap this around. Okay, first of all, you see there's an object here at the top, the keyword, and that has an extends app thing. So when you have an object, for now, just think about it as is a normal class. It's a class that extends app. So when you extend app, it actually gives you a main method from the app class. So you don't have to write a main method at all. Anything you write within this will be executed like you have a main method. So that's one feature. And that's not there in Java. Please keep reminding me if you see something in Java and I've not mentioned it. So because it's been a while since I wrote something on Java. And this is a case class. So this is very similar to what you have seen in records. Just think about it like a record. And this is inverted here, if you notice. So you write a Scala code or any other code apart from Java, even Python also. And then you write the name of the variable first and colon, and then you write the type of the variable you have here. So I thought it will be a good opening because we have a monthly meeting planner. I should add more meetings as well. So we have a case class called speaker, which is me, and I have a topic and I have some description, which is not really visible, but I'm saying Scala is not dying. It's still there. And then I have a case class, which is garden state jug, and we have this month meeting. So it has some parameters like month, speaker, we have a date, we have a start time, and then we have a location as well. Start time, start date, and a location, which is somewhere written here. Oh, okay, yeah, now it's better. So we have all these characteristics. So it's very similar to what you see in a record, simple. And then you have, and I've created the object. So if you look at the line 5, I have many things happening here. Number 1, I've created a while object, which is preferred over a var object. If you try to create or change values of a while object, it will throw an error, compilation error. It will not allow you to do that. And if you try to change a var object, you can actually do that, but it's not preferred. The other thing that Scala architects thought about was, writing a new keyword is really lengthy. Let's not write that. So they actually eliminated the need of it. And you just see that on line 5, I have not used the new keyword. I've just created a speaker object and I've added all these values here. And this is because a case class has an apply method, which actually gets called when you create the object this way. So it's an internal implementation that really happens. Good so far. I have created 2 objects. One is the speaker object and one is the jug state object. So it's a July meeting. We are meeting here on July at 5 p.m., 9th of July. And I just wanted to print out. And here on line 7, you see something else as well, something you don't see in Java now, and I don't know when we are going to see again in Java, which is the string interpolation. I think this is the best feature of any programming language, hands down, which Java should have, and I really, really want Java to have this feature back from any of the jugs. So if anyone is listening, please get it back. But this is a very good feature that you have in Scala that you can use, and you can just inject the values of a July meeting with the speaker, which is your object, and then you can actually call the topic, which is the other one. Mind it, you can actually call methods as well. So you can call a method which is there, which I've just created a simple example, but you can call a method as well, like toString or something in this. And so this is one example. I just want to stop here. Anyone has any questions, or am I just talking to myself?
Just a comment. Java was string interpolation, what they called string templates, was in preview.
Yeah.
In 23,
I
and
remember
somebody found something wrong with it, and so they yanked it out before ramp down time. So they're working on it. They're trying to get it, but they want to get it exactly right, which is good.
I agree. And I totally feel that it's going to bring the star to the Java language once it has it, because as a developer point of view, every day we write strings like that or something similar as well. So, it will be nice to have a feature. That's why I'm crying about it. So, okay. So anybody else has anything before I move on? Yes.
Oh,
How does Scala handle if speaker is null in the string interpolation?
Oh, good point. There's something called as option as well. So you can use the option just like Java has it. It has it. It's a bit different syntax, but it's the same thing that it's doing. That's a good question. Yeah. Okay. So I have something else. So this was kind of concise syntax, but I have another one to show as well. So bear with me. I have one more thing to show. Okay, we can talk about this first. Okay. Since we are here. Okay. Here I have a companion object. I think I talked about companion objects for like 3 slides and did not show you anything what it was. So it was bad part on me. So you have a simple class. Scala has classes as well. Like I showed case class, it has a simple class like Java has, which takes some parameters, and it prints out something. The thing that you see here, there are 2 objects, 2 classes actually. One is a class and one is a definition called object. It's a slightly different than class because the object keyword makes it, first of all, a companion object of the person class. The other thing it does is that it can share properties between them, even if they are private in each of them, they can talk to each other. And this is a very simple singleton as well. So you have any instance you create of person, it will be a singleton object created for that. It's like a factory method as well, which you can see in Java. I have a similar example in the code in the repo, which has how Java does it. So you can see and compare the same functionality that Scala is doing it. You can do things in Java as well in a slightly different way. And again, you see the string interpolation and there's no new keyword. So you get away with new keywords, so to speak. But yeah, and the same thing happens. So you have a main app, which is your object class. It's your starting point of your application. Funny thing, good thing, actually. So there are many ways to have a starting point of your application. This is the old syntax. This is extends app, which is an old syntax that Scala 2 used to have. Now with Scala 3, they have an annotation @main, which you can do it at any of the methods, and that can be your starting point as well. So I'll show you that example as well. Okay. Okay. I guess we'll look and see it like this. I'll just forget about this one. Okay. So this is again, I thought it will be fun to create custom operators. So you can have any operator created with your own needs. So Scala, since the language works well with Spark, and Spark has a lot of operations, you can see the analogy why you might need it. But sometimes you need to create your own custom operators, which Scala architects thought, and that's why you can create anything with that, and even the names you can define it. So you just have to do those backticks, and you can add anything you like. You can actually write a whole new with spaces, names, and everything, and it will work fine. So one of the cool things. And if you see here, oh yeah, I can highlight here. If you see here, it's just creating an object and, you know, updating the list. We should run this way. It's just creating an object and adding a heart at the front as well. So it's just printing out, but even when it's printing out, it's actually returning a unit object. So it's kind of not returning void, it's returning something in return, which is what Scala is really about. It has to return something. So yeah. Okay. I'm going to keep going it through one by one, which I think that would be the best way to do it. The next example is I have of the dependency injection. So I told you about we use Spring frameworks. How many of you are familiar with Spring framework? If you are, so you know what I mean. You annotate and inject your objects into classes, and with Scala, it's actually you can do that directly here as well. So I have a trait which is a greeting service, which has a method, or you should call it a function, which is a greet function and takes in a name and it returns your string. So if you see it, this is the return type and this is what you input. Because sometimes when you write it together, it was very confusing for me in the beginning, but you get it. So yeah, I mean, this is a greet function, and then you have another trait, which is a time service, which has a get current time, and it returns a string. And if you notice, there's no parenthesis here. If you don't need any input to your function, you don't need to write the empty colon. Is it parenthesis, right? Parenthesis, yes. Okay. So yeah, if you don't have anything to as an input to a function, then you don't need to write it. It's simple. And then when you implement, you have an implementation. So very similar to what you see in a Spring application, you have a trait, which is a greeting service that extends your greeting service. So again, reminding you that there's no implemented like in Java, it's all extends. And you can, when you combine them, if you were gonna use the same or a different trait right next to it, you would use with keyword to just write it and not the comma keyword. That's also another example, but here you don't have to need it. But here it's just overriding your greet function and adding a hello name. And on line 16, you have a time service, which actually gets your current time. And if you see, this one is from Java. So you see a lot of things are inherited back and forth from Java. And then when you have a class, you have, this is where you inject it. So you want to inject your greeting service with the time service so that you can greet with time, what time you are greeting someone. So you have this equals to, and this arrow here, this way, where you actually just inject both of these. Both of these are traits, so you are injecting it in the class. So this syntax is something which you don't see that in Java at all. So that's where. And then you have a simple function where you just want to greet people with time. So you get inherited all these values. So you don't have to even call a new keyword and get them all. You just get it inherited right away. And this is just my main method. So if you see, I do not have extends app here, and I have a new way of writing the main method, which is the @main, and then you just define what you want to run, and then you just create your methods here. And I just created a val of greeter, which is a new greeter with both these implementations here. So you can change it with time. It's a different syntax than Java, so you just have to get used to it around. But yeah, it works really well. So if you run this, Am I sure? I really wanted to take off all the other things from here, but I'm still work in progress. Exactly. So you get hello Scala. The current time is 5:48 probably. So okay, we are almost done. Bye. Anyways, anyone has any questions so far? I keep asking because if you have any questions, we can answer right now. Nope. Okay. Each one has to answer the quiz then. Okay. I talked about functions. So there's no better way for me to write this example. So we talked about higher order functions. And it might look a scary term. It's not a scary term. It's just like functions that have an input as a function, or you got using functions within functions, sort of a loop in a function, but not the same recursive loop. So here I have an example. I'm still using, you'll see a mix of the examples of extends app using the main method or not doing that phase as well. So there are various ways to write a Scala code, but you can choose whatever way you want. It doesn't really matter anymore. But the preferred way is the @main from Scala 3 version. So that's why you would want to do that. So let's look at line 5, which is the most interesting one. Here you have a transform method. So interesting part is that this is a type of the object that the function has. So remember those arrows here like that in Java, they are changed to this, and you can have more than one here. So again, your input is wrapped around here. Okay, so this is something really interesting happened to me when I was reading the Scala code written by other people, that I really had to divide and conquer which part is which is the method argument, which is the object type, and which is the return type. So I always did this. I started from the rightmost, like look at the equals to, and then I know that this returns a list of some elements. And then I go backwards and I see, okay, this is the input parameter. I'm not showing implicits yet, but please bear with me. It gets more interesting. This is the input parameter. So you have an input of list, a list of some object type A list, and it has a list. So this is your input of list, and this is your function, and you are injecting that function here. So remember, this is a pure functional programming language. So that's why it's a little tricky to wrap your head around. But once you get used to all these things, it's not that difficult. And I have created 2 pure functions. One is an increment. So on line 10, if you see, I have an input, which is an integer. I just want to add 1 to it and return the integer. So again, I go from right and look at this as an integer return type, and then I see colon, and then I see, okay, this is my method argument. This is how I actually try to read the code, which is the most important thing in Scala. Mostly you read code. So we have some immutable values here. I initialized the numbers here, and I used a list of numbers 1, 2, 3, and 4, which is kind of cool because I can also do this and it will still work. So something to remember, that why it is so concise, that you can write 1 to 1,000 numbers and in a 2-word sentence. Probably that's something interesting. Then I have a list of string which says hello world. So now I'm calling my transform method. Yes.
Yeah,
please.
I may have missed it. Did you already say what you mean by pure functions?
When I kind of mentioned it, yes. But when I say pure functions, is like everything is considered as a function in Scala. So anything that you see with a def keyword is a function. So a property of a function is that it takes an input and it gives you an output.
But why is it, what makes these pure functions?
It is because of, first of all, this one is taking in a function as a parameter and returning a function in return. So you can work with functions really easily. And I remember in Java, you have to define a class and write an @ functional, and then you do it this way. So even though it's possible with Java to do it functionally, but with Scala, it's more like inbuilt with the language. So that's why it's more like pure functions. Does that answer to your question?
I'll think about it.
Okay. You can ask me later as well if you're not satisfied with the answer, but okay. So okay, I want to increment the numbers using the higher function. So I'll transform them. So in transformer, I have a list of numbers as an input. So you see the numbers I created or the string that I created. So consider A as a list of integers or int. So this A on here, line 5, is int, and this B here is string. Just try to think about it in your mind that way so that it becomes easier to understand. And you have two functions created, which is incrementing, and then the other one is converting a string to an uppercase, similar to that. So you are transforming your numbers, and yeah, let's see what you get first, because wait, why do I have a breakpoint here? Okay, let's run this and then I'll explain. While it is running, I talked about pattern matching, and I'm pretty sure you don't have this in Java. So in this pattern matching example, to print any results, so first of all, think about the function as it's just creating a list of numbers and adding one to it. And then it has created a list of string and just converted the entire list to an uppercase list. That's all. Nothing fancy happened here. The next part that I did here with pattern matching is that actually I deconstructed that list. So this here and here, they are actually deconstructed objects of the list. So you get a default method in each of the lists from Scala, which is a head and a tail. And this is a double colon. And there are few more cases of using double colon, but you don't have to be scared of it. It's just one or two usages that you'll see here. That's why it's hard to remember, but that's where you remember. And if you notice that there's a nil as well. So nil is where it's kind of null, I want to say. Please don't quote me on that right now because I don't remember exactly, but I'll figure out and let you guys know. But it's somewhere between null and empty list. So it doesn't find anything on the list. It looks for, it matches with nil, sort of that. So this is a recursive call. So this goes, and we should actually see the output and then see what it is. So the head of the object was 2, and then 3, and then 4, and then 5, and then it went to an empty list. And similarly, the second list was called, and then it was a hello and the world and the empty list. If you have any questions, you can ask right now. Yes, please.
So I know in the pure functional languages, they don't believe in loops, only recursion. Where does Scala fall on that spectrum?
That's a very, very good question. I'm so glad you asked it because I forgot to mention that. So Scala also doesn't prefer for loops. They lean towards recursion, but that doesn't mean that you don't have a for loop in Scala. Actually, you have a for comprehension in Scala, which is like, yielding the values of or doing some operations on the entire list. I have an example here to show as well, but yeah, in a pure functional way, you don't have it. But since Scala has to live in the world where people write for loops, sometimes. It's still there, but please don't write for loops more often in Scala. That's I would recommend.
So did you say they don't have a for statement? They have only for comprehension?
They have a for loop and they have a for comprehension as well, which is like a extension of a for loop. Let me give you an example as well. I'm trying to
We
find.
can wait. We can get to it.
Yeah, I'm just going one by one right now because I want to cover all these features with you, which is kind of, I realize we are 1 hour already, but I want to show all of them. These are really nice features to have. So we did see some higher order functions before. I wanted to show them again. Again, the language looks complex, but I'm just giving you tools how to simplify it again from the right side. If I look here, the return type of this function is int, and then this is the input parameter. Actually, this is the input parameter, the entire stuff. So you have an integer, you have a x integer, a y integer, and then you are passing in a function. And that's why it's the higher order function, because a function goes into a function sort of way. So you have operations like add and subtract, which takes input. And if you look at this underscores, these are newer versions of Java. They do have it as an unused variable, but this is something which I won't call it unused. This is something which is defaulted, like you don't have to write it. It's actually unused as well because you are not using it in this context here. So you are just writing it underscore. Now that I think about it, it's unused here. So that's why you don't have to write any names of a variable here. You just write it underscore plus, and all I'm doing is just adding 2 numbers. And in the second one, I'm just subtracting 2 elements. So that's where it goes. And this is where I'm actually just calling it. So I have an apply operation, which goes in and uses this, where is it? Yes, which inputs has 10 and 5. And then you say, okay, I want to use the add function to 10 and 5. So you go ahead and just inject that function into the existing function, and that operation is called. So whatever you are writing, if you are adding, it's sort of, so if you notice here, there's no apply method. They're all functions. So even the line 10, while add, they are all functions. So anywhere you see an arrow like this is a sign that there's something function existing here. So just to give you keywords here. So you just want to add 10 and 5. You want to subtract 10 and 5. So you just use it this way.
So on line 11,
yes.
Do we just automatically assume that the first the leftmost underscore applies to the leftmost
yes.
of the 2 arguments? And
yeah.
Right. Okay.
Yeah. And that's why it's like it's called concise syntax. You don't have to write a lot of stuff, and it's assumed
that's a little bit different from Java's wildcard syntax.
Yeah, that's true. So good observation. Thanks. Similarly, you have functions like, you have a square, you want to just multiply it. By the way, this is also an operator in Scala. This is actual method, or you can call it a function. That's an operator written in Scala. So everything from plus, minus, all operations that you're doing, it's built in Scala by default that way. So I don't know why I wrote it twice, but okay. I want to print them out as well. So let me run this while I explain this. Again, I have a small example of immutability because, you have a val, which is an integer. And if you try to override this, it will start complaining. So when it will throw away everything for you. And then you can output anything. With pattern matching, does anyone have any question, or I will put a quiz right now? Because I see something different. Have you noticed anything different than Java?
Lots.
Well, for instance, you have something which is not a default case. You have an underscore here, which is also similar to function calling, right? But it's since everything is a function, you see that here as well. But there's no switch. It's a match. You can write primitives in here, which is technically converted into an integer object automatically. And you have deconstructed a list here, which is on line 42. I don't know if it's there in Java yet. Do they have it in? I thought record deconstruction is there, but not list. Barry, do you remember? No, no. So I think line 42 is not possible in Java, but correct me if I'm wrong. But so that's why I said, it's really powerful with pattern matching than any other languages right now. And also you see here the any keyword. Any means you can have any return type here. I think any is like object class here. So you can have anything. Okay, so what else did we have? Okay, we can print it out as well and see what it gives you. So we describe the function here, and we are calling it here. So if you pass in one or hello or a list, it should actually return you and describe or try to describe it for you to element list. Oh, and something else as well. Okay. How's it going, guys? Is it too much? Should I go to a difficult topic, or are you okay? Okay, fine. Yeah, I don't have 11 o'clock, but I'll try. Okay, so this is something I don't think any of the Java developers can wrap their head around, which is called implicit. Trust me, it breaks my brain when I see it for the first time. And the problem with implicit is some of the IDEs, I don't want to name any, but some of the IDEs, sometimes they misinterpret it. So it can be hard to look at the code and, see if it was what was actually a fix for it. But you need to understand the concept. So let's say you have a class and you're creating an object, but you have sort of an idea that the object should have certain properties, which I don't want to expose it to a client, who's creating the object, but you want it to be, slipped in somewhere there, something like that. Like a database object, you don't want a lot of details to be exposed to your user who's creating an object of your database data source, but you just want it to be attached to it somehow with a compiler knowing that, okay, this is something you implicitly want the object to have, but there's no way to create it for you. This is something similar that is created with implicit. So again, this is a different way of writing a main method. If you see, this is more like Java way. That's a main method in Java. So you have implicit val multiplier, which is 5. It's kind of a multiplier factor that you want, but you're only calling a multiply. So if you see here, if you don't look at line 4 and you just see line 8 here, it's confusing because where are you getting the multiply from? Basically, it's actually injected by the compiler. So with the use of a implicit val, you are injecting it in the function call. So when the multiply function is called, you have an implicit object int here. So that's why you don't see any brackets here and passing on any variables around here. This is how implicit works. You always have a companion. So you have a variable which is an implicit val or something. Most likely it's never going to be var, but implicit val. And then you have a function which is actually taking that implicit. So behind the scene, what happens is that you are calling your own method, but the compiler is actually injecting that value, looking at it at the keyword, and it's injecting that value in the function call. So you don't have to call it that way. Something similar. That's an implicit. I want to do one more thing. How are we doing, by the way? Good. Are we okay? Okay, so this code should be familiar to a lot of you. This is an object. It's a main method here, similar to what we had. We have an array list, which is a Java array list. And instead of having the, what do you call those? The like
Angle brackets.
angle brackets. Yes, sorry for missing that. The angle brackets, you have the
Square brackets.
I'm sorry. So instead of the angle brackets, you have the square brackets. So the syntax is different, but even with the different syntax, it's actually a Scala code that's using a Java list, array list. And you just add your elements here and you just print out like you normally do. And you can just convert them into your Scala list as well. So you have the option to go back and forth and convert a Java list to a Scala list, which will probably make it immutable as well. So that's where you use it. And then you just use the filter. Did you notice that you don't have to use the stream method and do all the operations? One of the things that is concise and easy to use. So let's try and see what it generates. Okay, so this is my Java array list, and this is my Scala array list, actually. So the point is that Java and Scala, they work so much together that they have all the compatibilities. You can use Java libraries within your Scala code, like time API, Java time API, or string is actually there in Scala by default as a Java library, Java function. So it's all converted and available to you. What else can we show today? Let's see. How are we doing? Oh, I did not show this one. This was my favorite one. Okay, let's see. So I talked about type inference, right? How does Scala determine the type? Let's see if we can do that here. So the first one is very simple. You know that the Scala interpret this as a string because it's a normal string. This one is represented as a number. So in Scala, you don't have integer, you have int as Scala. Here you have a type is inferred as a double because it's double. It's the same way as Java. If you write a function here and you don't specify the return type, this will be inferred as, did you notice I did not write :int here? So the compiler is smart enough that it knows that you are doing an operation on integers, so it will convert it into an integer. Just be careful when you write a recursion code, you might have to specify a return type. Other than that, you are almost good without writing any return type in Scala, which works wonderfully. If you look at line 16, oh, did I miss this one? Okay, so this is also an example of string interpolation where you have converted a where you have a string and then you have a name variable injected in it. So that's also the return type inferred as string. And in collections, if you look at it, this is actually inferred as a list of integers by default. I think if you write the keyword that I wrote, like 1 to 1000, you might face an error that it's not a list by default, because I tried it the other day and it converts it creates a range object. So you might want to use a toList method to just convert it and use it. But otherwise, by default, it's just a list of integers. Here you have a map as well, which can be easily inferred as a map of string and integer, which I think in Java, if you do it just with var, you might get a map of object, as I remember. But yeah. And again, here, if we come to line 23, you have a list where you have all these numbers and you're not required to use the stream method. You're just adding a function here, just like what you add in Java. A function call is here, which is an arrow and greater than sign. So this is all inferred. And same with this. This is inferred as a list of integer because you're doing multiplying the list by list elements by 2, and then just you don't have to use a collect method or do anything like that. Again, with filtered, you have this, underscore again, which is the current object, which you are, think of it like a stream. You opened a stream and then you are trying to filter out on each object, and then you are just using the underscore. So it's like very similar to the Java world that you want to do it with. So it gives you back a list of string here. Again, with pattern matching as well, you can have type inferences here, which is any type is detected by default. So it will tell you by default, and there's no default keyword. So remember that it's case underscore is kind of a default here as well. So this one is here. Very simple. So this is the one which I was talking about. This is a for comprehension. This is a for loop, which is kind of yielding things for you. Again, this is a for comprehension, but this is again a function in between. So you are traversing each number and you're multiplying it by 2. And then when you call the yield keyword, it converts it back to your list. So that's the return is actually a list of integers here. So this is an example here. So, and I like this one because this is a anonymous function. So this is confusing, but if you start from here, from the right side, you see this is the function. So it goes from here to here. So you have an integer getting into integer. So you are incrementing the number and then returning it as an integer here. So that's it. It might look complex, but you'll get used to it. That's what I would say. This is also a example where you can use a for loop. This is an interesting for loop actually, because you have created a case class person and have added some people in it. And now you are trying to print their ages with the name. And so I don't think this is possible in Java. Correct me if I'm wrong, but you can deconstruct the person object and then use this to inject the values here. So it's actually kind of shorthand for a person name. So this will print here.
That's supposed to be like a lambda, but backward?
Yeah, it's kind of, yes. It's a backward lambda, yeah, you can say. But there are no lambdas in Scala, actually. So they didn't need it.
Well, the anonymous, or did you call it anonymous or?
This is an
named
anonymous
function? That
function.
line 54, that's kind of a lambda there.
Yeah, but it's not, it's a function. I would still say it's a function. It's a lambda, but it's a function. It's a lambda in functional.
Okay.
Way. Okay, let's agree to that. Okay. Anyone has any questions so far?
Are there any features this language doesn't have? That was a sarcastic question. Ignore it. I'm just being silly.
It's interesting because this language has so many features and keywords. I could spend my entire evening in it. I haven't even talked about triple colons, so to speak. I have an example. So everything is there in the repo. If you take a look at the repo at home or later, you can ping me on Twitter or somewhere and curse me that this is wrong or something, but you'll find all the examples there. So because it takes some time to get your head around them. But yeah, once you have noticed everything from there, it's actually not that bad. It's really interesting language, I feel like. And there are a lot of use cases for Scala because Scala is still very famous to work with Spark. So if you have big data applications, they prefer Scala with Spark. I don't want to get into Python, so yeah, let's keep it that way. Anyways, if you don't have any questions, I think I have gone through all of them. Let me see. We did talk about implicit and interoperable. Meta programming, let's not do this because, so Scala, I'll define. So meta programming is something which is similar to reflection. In Scala also has something which is reflection in Java, which is called a macros or inline variables. I don't think we should get into that. But yeah, I did wanted to mention the Scala 3, which is the version that I've mostly used in all the code samples that you have here. With Scala 3, one of the key features that I liked about is that you don't have to even add curly braces or parentheses when you create a function. Just like if you're a Python user, you can just do it like that. Which is, I think, in a Java world, we still have we call it a Java world. It's very interesting to have no curly braces or anything, but indentation is important again. By the way, I did not mention you don't need to have semicolons at the end in Scala, which is one of the key features. You can still add it, but it's not required anymore. Unless you want to add two lines in one together, then you need to add one semicolon to break them down. It's a very simple control structure. You'll see in the examples, you have a if condition, so it uses if then condition, and it uses a then keyword, not the else keyword. So that's kind of simple, just one liner. You can use them. Unions and intersection types. I have examples of it in the sample code, but I'll just briefly mention. At times when you want your object to be one of the two types, like let's say I have a string object, but I also expect somewhere it might be an integer when I'm calling it. You can use a union type there, which will actually allow them, either one of them, to be created. With the intersection types, it's the same, like, remember Venn diagrams, the union and intersection. So if it's if it's both string and integer, two different types, then it will allow you to create the objects. Otherwise, it will not. It's strong typing, then the union type, basically. And then it's the conceptual abstraction. I have examples, actually. Let me point it out as well, because it's a contextual abstraction, not the conceptual. I'm sorry. I created this 2 days ago because I could not get my code working. So there's a thing called in Scala here. in line 34, you see a given keyword. So what you're doing is you are trying to order your list in a certain order, you can see. So it's kind of using your order here. So using and given are like, they are like implicits, they work together. I don't want to confuse a lot here, but this is a new feature in Scala 3, which is meant to do the same thing what implicits were doing, but in a more controlled fashion. Because with implicits, you can, if you have more than two variables which are defined with the keyword implicit, then the compiler may get confused. But if you have a given and a using merged together, it's more of a tight combination of these keywords to be used. I think that's why they added, and they are phasing out implicit. So I guess you don't have to learn it. So trust me, they are phasing out because they saw that they were. I read that people were abusing implicit, so they decided to take that option away. But anyways, meta programming, like I talked about, with Scala, you can write your macros and all these cool stuff as well, which is, you'll find some of the examples in the repo. So I think that will benefit you all. And enums are actually added in Scala 3. They were not in before Scala 2, in Scala 2 version, which you should be happy about because enums were always there in Java. And opaque types. So opaque types are nothing but an alias object. So it's a combination of an object, like let's say you create a password and you don't want to show that password to anyone. So you create an alias for the password and you call it opaque. So opaque is like, you're going to use opaque, but behind the scenes, it's going to call your actual password thing, something like that. So who's ready for quiz? I hope I didn't bore you to sleep now. But
I doubt if we'll pass the quiz.
wait, this is interesting. Okay, case classes in Scala have an inbuilt apply method. Please. Well, technically, no. Nothing is true or false. You have to guess. At least give a guess. Yes, it has an extra method which is not there in Java in records. So there's an apply method, and that's why you don't see a new keyword there. You just call directly into the you can say constructor.
So before we continue,
Yes.
there's a Y in the true box and an X in the false box. Is that already an answer of some
No,
sort, or?
I haven't written any answers. No.
Okay, so I'm just wondering why. Are they both? All right,
No, these are not answers. This is just true or
whatever. Okay, all right. I just wanted to know what the rules are.
Okay. If
False,
you were
false,
listening,
false.
then yes. Yes, so traits in Scala, they can hold the state of the object. So that's why in Java, you have a static keyword, or you don't have a static keyword. All the variables in interface are by default constants, which is not the case in traits. That's why they can hold a state of the object. Okay. In Scala, it is allowed to use Unicode characters such as emojis as class or method name. Anyone for false or true?
We just got those answers.
We got both the answers, right? Well, you can have any name you want as a class or a method name. You can go crazy about it. Just use a backtick and you can go crazy about it. So, wait, it is allowed. Yes, it's true.
There's something new in Java with that, or at least it's being worked on.
It's being worked on, I think so. Yeah.
I remember it was one of the draft JEPs that would allow emojis.
Well, people, here's the thing with Scala, it's so liberal to use anything that sometimes I've seen people using weird keyword notations that you won't even understand. But you need to be careful when you are writing such a method name or a class name, because you're not just writing for yourself, you're writing for other people to read it and understand that what it means for it. So just don't do it for the sake of doing it.
There have to be situations where there are names that you could try to use that are going to make it impossible to parse.
Yes.
So,
Yeah.
yeah.
Yeah, be careful about that, because even when you write it, the other systems that are processing it, they might not like it. So yeah. Who knows this? Object keyword is used to create a singleton object. It's true. They are used to create a singleton object. So remember the concept I told you about companion objects or not? Not even a companion object. If you don't use it, if you use an object keyword, it's gonna think about it like a static keywords in a static way. Not exactly the static Java, but it's always gonna create you a singleton objects. There's only one single copy of it. This is my favorite one. For comprehension. I told you about the for comprehension where you had the yield keyword. Are they only solely used for iterations over collections?
That's got to be false, right? It's got everything gets used for everything else in Scala.
Yes, but that's not why.
Okay.
But yeah, I mean, you can use function, you can use it like a functional way. You can treat it as a functional way, but it can be used for iterations as well. But like I said, Scala, since it's pure functional, they don't like for loops in general. So even though you have them, it's not really preferred way of doing it. Okay, implicit is used to define methods or values that can automatically be provided by the compiler. Why did we use implicit anyways? We didn't like it. It's going away in Scala 3. We don't care. Any thoughts on this? Sorry? What is the native keyword in Java? I forgot actually. Do you know? Do you remember?
Kind of old school, right? You have old compiled with C, but you can port to Java.
Yeah, it's for third-party APIs or something.
Oh, native keyword. Oh,
Yeah, it's
um,
doing like correct database code, reference like binary.
oh, I know what you mean. No, not. They are two different contexts actually. Implicit is it's not the other languages. First of all, it's the Scala only. But it's like you're calling a method, but you're don't passing in the arguments, and you assume that the compiler will pass the arguments for you. So think about it in that situation. That's where you have implicits and keywords. So compiler is gonna provide you with the values, so you don't write it. So implicits can actually confuse you a lot more in Scala because you don't see the arguments passing in the method, and then you think about it and you say, oh, where does this call even went? So that's why a lot of IDEs gets confused when you're trying to debug a value or a method which is, which uses implicit, and it gets complicated that way. Who said?
Say that just one
The
more
question was, could you elaborate on how it was abused and why they took it out?
Well, they haven't taken it out, so you can still use it in Scala 3, but they are planning to take it out. I think what I read from all the discussions is that, first of all, implicits are tricky for compiler to actually kind of find it. Number one, the IDE support is not really great, I would say. This is my personal experience as well. I hated implicits from the beginning. And it's confusing because you can write implicits everywhere without even how will you test the application? How will you test your function if you are passing in the argument and you are expecting the compiler to pass in the argument for you? So you don't really know what is the argument, what is the input to the function. Your compiler knows it. So it gets very messy very quickly if you are trying to use multiple implicits in a single file. So that, how will the compiler tell each other? And sometimes I've seen you have to import something with the Scala libraries, which gets really complicated. So I think Scala architects have realized that this is not working well, that how they wanted it to work. So that's why they are phasing it out eventually. I think and that's my personal opinion, by the way. I have a disclaimer like that. So, okay, pattern matching in Scala is limited to few types. Please, please, please tell me, you know that.
No.
No, it's not. It's available for every other type in Scala, so you can use it anyway. Scala's collection library defaults to immutable collections. Yes, that's true. By default, it will create immutable objects. But remember, when it creates an immutable object, you have to remember, if you call a function over a function, you may end up having multiple objects created. So it's like the string is a immutable class, right? So you create a string object and you add on it, and do any operation, it creates another string object. So it works the same way with collections as well. So be careful whenever you use any of the variables or the collections which are immutable. Okay, every statement must end with semicolon. Yes, that's true. All method types must specify a return type. No, it's inferred. That's why it's inferred.
Yeah, that's why I was going with that.
Okay, so this is a typical question. So a method has to return something, even if it doesn't return something, but you don't need to provide a type of what you're returning to. So that's why it's tricky. I have a few links. I feel like I got enough with all these 3 links to give a presentation here, honestly. But there are a lot of good resources on the official website of Scala. They have a good references you can make with Scala for Java developers. Rock the JVM, I think this is the great tool if you really want to lightning fast learning basically into Scala world. I think Rock the JVM, they have great YouTube videos as well, and there's a website. I don't think you need to do a course, but there's a free resource available on the YouTube. And the third link is basically your go-to tool. So you don't have to write code in like an IDE or something. You can just write it online. It's readily available. You can actually change the version numbers as well. So it's all available to you, I think. So thank you so much. I think I'm done.
Yeah, all right.
I had a picture of a smiling developer, but my computer was crazy in between. But you can assume I was smiling at the end when I learned Scala after a while. But any questions or any thoughts? What did you like? You did not like? Scott is saying something in his mind. I was just thinking of that.
That's a birthday celebration.
Yes,
The donuts, yes.
it's Neha's birthday today.
You came late.
Yeah. That's what happens when you arrive late.
Well,
Any
thank
other
you so much
questions?
for coming for this presentation. I hope I made some of the nuances of Scala easier. If not, then please let me know. I'll definitely try to do a better job. But I really hope you give Scala a try. It's really interesting still. The community is very vibrant, not like the Java world that we live in, but it's still good. I think it needs all the support it can get. So I'm really passionate about Scala as well as Java. So
So we had, I think it's more of a
I'm not
comment.
talking about Python, by the way. No Python here.
No. I think we have, I don't know if it's more of a comment than a question from our pal Bill Brutzman we refer to him as Wild Bill. It says here, not requiring a type incurs an adverse performance impact.
That's a good question. I don't think there's any performance impact because actually Scala is named as scalable. Like that's the name they chose because they wanted it to be scalable, performant, and Scala works with the big data applications really well, better than Java do. So I don't think there's a performance impact because I think there's a Scala compiler also doing. So there's a Java compiler and there's Scala compiler along with it. I think that's the version that's actually doing a lot of work or backlifting for you. So that's why.
Okay,
Yeah.
thank you. Yeah. And so, and I finally started reading the comments on YouTube and folks who are participating and answering the questions and
Oh,
you know,
wow.
in
Thank
your
you.
quiz. So,
Thank you so much for helping.
all right. Any other questions for Neha? Yeah.
What kind of advice do you give for Java developers that want to learn, to make it easier to learn Scala? My first try was, I felt that I was missing some classes or some knowledge around functional programming.
Mhm.
Probably was the hardest part for myself. Not sure what you have perceived and what is your tip, your advice for people that are.
Well, I honestly, personally, I started looking at Scala code in 2022, and I was lost at first as well. So I'm with you. I think it gets complicated too quickly because there are two ranges of Scala developers I've seen. One, they are purely functional. They don't have any exposure to Java or of any of these languages that we know. So they write Scala code in a different way than we do. So it takes time, first of all, but I would recommend resources like, you know, IDE support is really important. That's number one. So use IDE. I use JetBrains. Scala Metals is also good on VS Code. So I tried it on both, and I think the IntelliSense is quite good. So you might want to start there. Plus the Scala official website, they have a really good code snippets. So you can look at those as well as an ability to start. You can look at the GitHub repo I have, and if you have any comments, because I've tried to add all these code snippets there, some of which I've not even mentioned here because I don't want it to go over the head for everyone. But it takes a while to switch your brain off from a non-functional iterative approach to functional approach, but it should not get complicated that much. Honestly, it should not. So I don't know if that answered your question, but yeah. Thank you.
Okay, anybody else? All right. Can you flip back to the
Oh yeah.
to the slides and also refresh it? I updated it while you're during your presentation. So
Okay.
sorry.
Do I have to refresh it? I'll just refresh it.
Yeah, just in case. Yeah,
Is that what you want on the screen?
I think so. Yeah, I think
Okay.
that's right. It was right after your
Thank
picture.
you.
I think. Good. So let's see. Yeah, that's what it was. Okay, whoops, I went too far. All right. So the usual stuff at the end. Our upcoming events, not outside of here. Dev2 Next in Colorado. This is organized by Venkat Subramaniam at the end of September and October. The Open Community Experience, formerly known as EclipseCon, is in Germany. So have your passports ready if you're ready to take a trip to Germany. So that's at the end of October. No, it's my anniversary on October 24th, so.
There's someplace that you're not going?
Yeah.
We may go away just for us. I'm not going for a conference, right? So, QCon San Francisco is November 18th to the 22nd. All lined up to be a dedicated reporter. I did last year's event. That was fun. And I think that's it. There are others. I know there's all the DevOxes and, but have to put those on there at some point. Anyway, so coming up for us, I mentioned in my email, there was a lot has changed since last month's meeting. So when I first said that we won't have an August meeting, we may have two. So more details to come. But when opportunities present themselves, you got to take advantage of. Well, not taking advantage. You can't say no, right? I mean, So we know for sure. That's an interesting idea. We'll have to talk about it. But anyway, so title to be determined. Dimitri Choiko from Bellsoft. We talked about August 13th. He's going to be in New York the week before, so I'm not quite sure. But in any event, and also Rustam Mamandarov, who was here in June of last year, is also going to be around a week later. So we're working on all that.
He's coming back in August?
Yes, but he'd be on vacation. But
Okay,
he's
all
more
right,
than happy to. He'll be more than happy to do talks for us in New York, and I'm working with Jason Young in Philly to see.
Yep.
So anyway, and then this has not changed. Marcus Hellberg will be here to talk about LangChain 4J in September. A big change is we had Mo Gote set for October, but thanks to Mary Coker, who's here in the audience, interacting with Scott Strohs at the InfoQ Dev Summit Boston. So so anyway, so he'll be in New York that very same week. They already had this room booked for October 8th, and I'm not sure if he's going to go to the other two jugs, but he'll be here for that. We met Rajiv Shah at the New York Java SIG last month, and he's all set to present to us on November 12th about real-time data processing. I think that's grid gain. And then, as I mentioned, Amol, December 10th on Digital Signatures Decoded. And hot off the press, Scott in the back, assuming you're okay with January 14th of next year. Do I have that there? Yes. It was in your Slack message. So anyway, just
I just want to make Barry run up and down the stairs. Clearly. Oracle has officially announced the Java 21 certification. Gene and I have been working on the book for months, but haven't been allowed to talk about it until they officially acknowledged it. They released it, I believe, this week, whatever, I don't know which day, maybe 2 days ago. So you can't sign up for it yet, but you will be able to sign up for it soon. Our book is coming out in October, somewhere between October, December, and that's about it. So if you're interested in the Java 21 cert, it's now available, or will be available.
cool.
Oh, boy.
All right, so I'll get send me an abstract and title and all that good stuff at your convenience. I mean, we have a little while, right? So yeah, the great thing about this, right? In the early days of the Java group, when we were ACGNJ, how many times Barry and I would somehow communicate and say, well, you got anything? I don't know. Do you got anything? And we'd fly off the seat of our pants to do a topic of some kind. So those were the old days.
I'm proud to say that I gave the last seat of your pants talk at this group meeting years ago. After that, it was all real talk.
Yeah. Well, we did some fun stuff,
Yeah.
And when I made that comment about 11 o'clock, back in the day, we would go to 11 o'clock at night. So, so good times. So anyway, so that's that. And as far as the Friends of Garden State Jug, so the Boston group, they're 2 nights from now, they're doing a talk on, let's see, convergence of programming language feature, a Java, Scala, Kotlin illustration. Sounds interesting. And then, 3 Jugs are having their July event on the same exact night. So you see Pittsburgh, Spring AI, which is a new Spring project. They're on the verge of releasing 1.0. I think they have a milestone 1 or 2 release or something like this. So that's for their Dan Vega. We'll be doing that one. Fruit of the Loom. I love the title of that. So for the Chicago folks, all right, Loom and Virtual Threads, July 18th as well. And an introduction to AI with Spring AI at the Kansas City group. New York had their meeting last week. And somebody else is not. Oh, the Atlanta folks at the moment don't have anything scheduled for this month. So and we debut of a new image, thanks to Barry. He sent this to me earlier today. I don't know. Is it AI generated?
AI generated, yes.
So yeah, nice glasses of beer with chocolate. All right. So of course I'm the craft beer guy, and Barry is the chocolatier. So, so yeah. So everybody on the leadership team, advisors included, stick around. I'd like to take a picture of all of us. You know, if somebody can do that. We got Paul, Barry, myself, Neha, Scott, and Diane. so yeah, no, Jonathan couldn't make it. He had a work-related event going on. So, but anyway, stay tuned for details about next month. We're trying to work all that out, and you'll get my email, and the website will be updated accordingly. So until then, oh, we have to get, yes, I'll run the. I noticed a few people have not signed in. Please do so. I use the sign-in sheets now to run my random generator application, which I should make available on GitHub so that everybody can see what I can. So, but only fair, right? But yeah, please sign in, and then I'll run the numbers tomorrow, and I'll announce a winner. So with that, see you guys next month.
Yes.